Today we're looking at a piece of software known as Git, and Git is very popular, and I'm sure many of you already know what it is, but it's essential to learn and use if you're working in a collaboration of people working on code. I originally intended this video just to be for people in my research group. I was going to teach Git, but I decided to also publish on my YouTube channel as well. So hello YouTube. The first thing we have to ask ourselves is, what exactly is Git? Well, when you're working on code with people and, one person's working on one thing, one person's working on another thing, the code is getting updated over time, you want to keep track of the changes that are happening to the code. You also want to make sure that there's no conflicts when people are working on code. For example, if two people are working on the same file and they each edit a bit of code differently, and then they want to put that in the main file of all their code, well, there'll be a conflict because each person will have edited it differently. The question is, which one do you use? And these are all issues that you run into when working with a team of people. Git is a piece of software that helps manage all those things. Essentially, it's version control, meaning if you have a file on your computer, it tracks what does that file and all the contents of the file look like as a function of time. So for example, here's the file at one time. The file gets updated, all its contents are different at another time, and then at another time, and it sort of continues that way. And the beautiful thing about Git is that it tracks changes so efficiently that if you're at one, state of the file structure, where all the code is a certain way and whatever, you can track backwards to get to earlier versions of what the file and all the code in the file look like. You'll see what that means in a second when we get started. So let's get to it. So the first thing you need is to have downloaded Git, and I'll put a link in the description for how to download Git. But essentially you have a terminal like this, and what you do is there's files on your computer. They're just regular files. And what Git does is you can turn a file into a Git repository. So that means Git knows it will track all the files in that folder. And what I mean by that is as follows. So for example, I can go to, this is my directory on my computer, and I'm going to go to the Git tutorial folder here. So cd git tutorial. And now I'm in this folder here. It's an empty folder. Now I'm going to make a folder inside this folder, which I'm going to make the Git repository. So let's make a directory, and I'm going to call it Git repo 1. So now I have a new directory here. So I can cd git repo 1. And it's just an empty folder. So it's a folder somewhere on my computer. It's empty. There's nothing special about it. But I have Git installed. So if I go Git, I'm going to make this a little bit bigger so people can see. So if I go Git init, what this is going to do is it's going to take that folder and it's going to become a special folder. It's going to become part of a Git repository. So I go Git init. It's initialized an empty Git repository here. So this means that all the changes that I make over time to files are going to be tracked. We'll look in that a little bit more. That's the special thing. But really, in essence, that's sort of abstract. What it's actually doing is if I look at the contents of this directory, so I'm not sure the actual command for that, but if I go to my folder and git repo 1, what it's actually doing, what Git is actually doing is it's creating this .git file here. And this contains all this information, and this says, given the folder, which is a Git repo, and all the contents, all the files and subfolders inside this folder, how is that changing as a function of time? I say time, but what I really mean is iterations, and you'll see what that means. And so this contains all the information. For example, I change all the stuff in the folder over time, and then this provides all the information to go back. I can go to any sort of instant in time, to see what the contents of my folder look like. So now this folder, since I called git init in the terminal when I was inside the folder, it's now become a Git repository. So now I can do things in this repository. For example, let's make a file and let's actually track the changes that happen. So here I am inside my folder, Git repo 1. Here's the folder, and I'm going to make a new text file. I'm going to call it sample.txt. So it's just a simple text file. And I can open it, and we can edit it. And I'm going to write some text here, essentially. So I have a text file. I've saved some stuff in it. And so this is now part of my folder. And remember that Git tracks all the changes that we make to things. So the question is, how does this work? Well, let's look into it with a little more depth. So the number one command that you use in Git if you want to see what's going on is you go git status. And this tells you all the information about what's happened. We need to help Git along a little bit. It's not automatically going to track everything as a function of time. It's going to track snapshots that we take. So we'll change the contents of the folder. We'll take a snapshot, and Git remembers that snapshot. Then we change things a little more. We take another snapshot, which is an instant in time of all the files and all the subfolders inside our Git repository. So what Git's telling us right now is that it has an untracked file. So the way that it works, we need to set up our folder so that we can take a snapshot. That's the whole point of Git in a way. And so, for example, you might change a whole bunch of things and you take a snapshot. Now, you may not want to, you may change 20 things, right? Say there's 20 different files and you take a snapshot. You might want to take a snapshot where you've only changed one of those things. Or maybe you change a bunch of, .py files, a bunch of C++ files, a bunch of other files, and you want to take a snapshot for, each of those files that you change separately. So what Git has is I like to call it a stage. It's where you stage the things. So here we've only made one change. So what we need to do is we need to say, okay, in our next snapshot that we take of the folder and all the contents, this is going to be one of those things that's included in our snapshot. So I need to go git add, that's the command. We're adding it so that we can take the picture instant of time of all the contents in our file. And we're going to add sample.txt. So sample.txt. So now it's added. So now I can go git status again. Again, git status is going to be your favorite command of Git. And it says, okay, well, there's a new file, sample.txt. This is a change to be committed. So we've added it, right? And the question is, how do you take a snapshot, right? We want Git to take a snapshot of an instant in time of what's happening to the folder. Well, there's this new thing, sample.txt. And if I want to take a snapshot, I go git commit. That's the command to take a snapshot. So Git will memorize the entire structure of your file and all the contents when I go git commit. So I go git commit. And typically what you want to do is you want to go -m and you want to put a message. You want to put like a caption for this snapshot that you take. What's so special about the snapshot? What did you change to go from the previous snapshot to the new snapshot? So here I would say add sample.txt file. So we've added a new file. That's what we've done when we've set up this snapshot. So now one file changed, it's taken a snapshot. So this is like a new snapshot. Now suppose we make another change, right? I go back to my folder, in my Git tutorial, Git repo 1. Maybe I make another change to sample.txt. Some text here, now more text, right? So I make another change to my file. I save it. And suppose also I create a new file. So I'll create another text file. I'm going to call this python script.py. So now I have my new script here, python script.py and sample.txt. And I've changed this and I've added this new file. So if I go git status, so what's happened since the most previous snapshot that I took up here? Git status. It says, okay, I've modified sample.txt and I've also added this new file. Now this is what I mean when I say the staging part, which is git add. That's the first command, git add. We're going to add everything before we take the snapshot. So maybe for this snapshot, I don't want both of these changes to be tracked at the same time in the snapshot. Maybe I want, the fact that this was modified, I want that first. So I'll go git add sample.txt. So this is one of those files in our folder that we're going to add to the snapshot. And so if I go git status again, it says, okay, well now this is going to be included in the snapshot. This isn't yet. So I go, all right, git commit -m message modified sample.txt file. So now we've taken a snapshot. So now we have our first snapshot where we created sample.txt, put some initial text in. We have another snapshot where we modified sample.txt. So now I can go git status again. Okay, there's still untracked file. So I want to take another snapshot, and that snapshot includes the python script.py file. So I'm going to go git add. And by the way, instead of typing out all this .py, if I want to include all files that end in .py, I can just go star.py. So this will automatically add this file. So we'll add this file, git status. You don't need to type this every time. This just tells you sort of what's going to happen. I could just go git add and then git commit -m added python file. So now we have another snapshot. So the question is, how do we see the history of what's happened? Well, I can type in git log. And this tells us all the different changes that we've made throughout. So our first commit was at 1601/2022, and it just says add sample.txt. So that was the first snapshot we took of our repository. Then there was this next commit where I modified sample.txt, and then there was a third snapshot, a moment in time of all the structure of my repository, where I added the Python file. Now, the beautiful thing about Git is because this is version control, I may be, like if I look at my folder structure now, I have Python script and sample.txt, but I can go back in time to one of the older versions of my file structure. And I'll show you how to do that. So in order to go back to one of these old commits, I go git checkout, that's the checkout command, and I'm going to add like the first few characters of one of these commits. You don't need all of them, it just Git will automatically know what I'm talking about. So suppose I want to go back to before I added the Python file. So I'll type in this number here, C7FC3D5. It's the first few characters of this, and it will check out this branch. And so I'm in what's called a detached head state. Don't worry about what that means, but it's basically like a trial thing where I can look around, make experimental changes, play around with the code, but it's not going to like save anything permanently. And so if I go here, you'll see that I'm now missing my Python file. I've gone back in time to an older version of my directory. And if I go sort of git and branch, so what I've sort of done here is I've created a separate branch. And so here's the master branch. That's the one that you are typically using. And then there's this branch here. This is that detached branch. So I went back in time, and rather than changing everything, I'm sort of on a new, what's called a branch in Git, and I'll get a little into that later. But the main thing of why I'm saying this right now is that, I have this, and you might think, oh crap, I've lost all my files in progress. But if I want to switch back, I can just go git checkout master. So now it's going to send me back from here to here, and this is sort of the all up-to-date code. Now it's back to master. I can type in git branch, and you'll see that I'm back on master, and it's deleted this, right? So this branch was just temporary. I went back in time. I could look at the history of the code. I could try out things, add new code. And once I went back to master, I'm now on master, and I look at my file again, and sure enough, I have the Python script.py back. Now, you notice when I switch back, I lost this branch. I no longer have this here. But suppose I wanted to create, and this is what you do in Git, you create separate branches so that, you have maybe a source of code and one person's working on, one version of the code, one person's working on another version of the code. They're making separate changes, and then in the end, you merge them back into the master branch. That's sort of the general idea of Git, and I'll get into that. But, suppose I wanted to actually make this a permanent branch. So I can go git, cycle through. I want to check out this part of the code again. So I type in this. If I go git branch, I'm on this, what's called the temporary branch here. In order to make it permanent, I go as follows. I go git switch C, and I'm going to call this before Python script. So now I'm on a new branch. And so I can switch between branches to switch sort of the file structure. And I'll show you what that means. So here I'm on my before Python script branch, and I can go git checkout master. And now I'm on my master branch. And if I look at the file structure here, I have the Python script back. And if I can go git checkout. So I can look at all my branches using git branch. It tells me I'm on the master branch. And there's this other branch here. I can go git checkout before Python script. Now I'm on this branch, and I don't have it anymore. So again, I'm going to go back to git checkout master, and now I'm back on the master branch. So I have two separate branches of my code. I have a before the Python script, and I also have after the Python script, right? And so these are like different states of the Git repository. They're sort of parallel. You can think of the version control and time as serial. It's sort of in order. But when I branch, I take it and I sort of create a new timeline of the Git repository. So two branches can be created, and you can make totally independent changes on these branches. So the reason you might do this is because one person might be working with one part of the repository. They're working on one job. Another person's working on a different thing. You develop them independently, and in the end, you merge them back together. That's the idea with Git. So I'm going to make a new branch called git checkout B for new branch, and I'm going to call it C code development. like that. So now I'm on a new branch, and I can go git branch, and you'll see that I'm on the C code development branch. And so now I can start adding some code here. So now I can open up a file, go here, and I can create a new file, and maybe it's some C code. So I call it ccode.c. So now I have a new file. I've added a new file to my directory, so I can go git status, and there's a new file that's not being tracked by Git yet, right? It's not going to be included in any snapshots or anything. So I need to go git add, and I'm going to go star.c. That'll add all files ending in .c. I'll add it here. It's now part of the thing. Now I can make a commitment so that I take a snapshot in time for this particular branch of the C code development. So I go git commit -m added C file, right? I've taken a snapshot in time, and I can go git log, and it tells me that I'm on my C code development branch. I've taken a snapshot at 1642 where I added the C file. Whereas in the master file here, that was where I added the Python file, and there's other stuff that's been done. So I've added a little script to my git config file on my computer. It's usually under like local disk users and then your username. And there's something called .git config. You can click on it, and I've added this. This is from an online thing. I'll post the code in the description of this video, but this just gives you a little way of visualizing the changes that you've made to your Git code. And that's the command here, git lg3. And so you can see this is the initial commit. This is where I first made the repository. Then I made some changes here. I modified sample.txt. I added the Python file. Then I made a new branch, and I added the C file. And you can't really see that here. It looks like it's all one branch. But typically what you do is you're working on another branch, and you have your master branch. And that's where, like, if you have a bunch of code, people will always download from the master branch. So you have your separate branch, and every now and then you're in your own branch. I'm in my C development branch, right, where I'm adding C code, and I say, okay, I have a bunch of C code I've developed. I'm in my separate branch, and I'm going to merge that to the master branch. So how do you do that? I'm going to go back to master. So now I'm on my master branch. I can check that by going git branch. I'm indeed on my master branch. There's the C code development branch, and I want to merge this C code development to my master branch. And for example, right now, if I look at my code here, if I go to Git tutorial, my Git repo, I don't have my C code. I'm on my master branch, and the C code doesn't show up. And I want to, from that development branch of the C code, I want to merge it to master. So for that, I go git merge C code development. So now it's merged all the code. If I go to my file structure, I now have my C code. Now, when you're working in a team, it very well may be that the master branch changes as you're working on your own branch. So you take all the code from the master branch, put it in your branch, you work on stuff, other people are working on things, the master branch gets updated, and then you want to merge back. So let's look at what happens there. So again, I'm on the master branch right now, and I'm on master, and I'm going to add a file, and I'm going to say new text document, and I'm going to say other work by other people.txt. This is stuff that other people have done in the meantime. And so I've added that new file. Now I need to make sure that it's been added to Git so that Git tracks it. Again, if I go with git status, you'll see it's not being tracked. So git add star.txt will add that file, right? So now the file is added. And what I want to do is commit. So git commit -m other work by other people in the main repository. So stuff has been updated here, right? So now if I look at my folder structure, and I go git repo, you can see that there's work that's been done. But if I switch back, git checkout C code development branch, so I'm on this branch here, you'll see that I no longer have that work by other people. And maybe in the meantime, I do some new code. For example, I could go new text document. I'll go more C code .c. So I'm adding stuff to the repository, right? And now the question is, well, I don't have all the same stuff that master does, but maybe I still want to merge this to master. Am I still allowed to do that? Well, the answer is yes. So I have my branch here. I can go git branch. I'm on my C code development, and I want to merge all the code from C code development back to master. So again, to do that, I go git checkout master. So I'm on the master branch, and I can look at that. That's all the code that if you sort of deploy your code, that's the main branch that people look at to take your code. And I can go, all right, so git merge, and I'm going to merge with C code development. Oh, and I need to also add that file. So I go git checkout C code development. This is a common mistake. And I can go git status. And this new code hasn't been added yet. So again, I caught myself in a mistake here. I created the new file. I have to add it so it can be tracked by Git. So I can go git add star.c, git commit. I'm going to take a snapshot in time. Git commit -m added more C code. Now I've added this file. And I can go git status. Everything is updated. Git checkout master. Now I'm on the master branch, and you'll see that my other C code is not here anymore. And so if I want to merge from that branch to master, I go git merge C code development. So let's summarize what's been done here. The master branch was updated in the middle of the C code development being changed, and now we want to merge them back together. And now I can go, I look here, and I have my more C code, and I have my work by other people as well in the master branch. And so now I can go git lg3 to get my log of what's happened. And this is where it really starts to become apparent of what's happening. So here's the very beginning, Wednesday, May 11th, it's got a timestamp and everything. I added sample.txt. I modified it. I added a Python file. I added a C file. And then I made this new branch here, right? So here's the master branch on the far left here. And you can see that this branch was made, and after this branch was made, this star here that corresponds to this, there was something that was done to the main repository. So I'm a worker here. I take the code from the master branch. I do some edits on it, and while I'm editing it, during that week of me developing code, well, someone else changes the master branch somehow. So I'm no longer the same. There's like additional stuff in the master branch, whereas I'm working with like an older master branch here. Then I make a change and I add more C code. That's where I made that file. But even though I did that, I can then merge this branch back to the master branch. And in the end, I have all the code here. So throughout this whole example, I've sort of been working by myself, right? And it sort of doesn't make sense to use Git if you're a sole entity working on code. For example, if I'm just a person making changes to code, I just do it sequentially, right? There's no parallel stuff going on. I just want to work on my code and make change after change after change after change. But if you have a big project of people and they each have their own roles, you don't all want to be editing the same thing. You want to make your own work development branch, make your own changes, merge them at the end. And it turns out that like if you have administrators or people in your group, when you merge at the end, sometimes there's conflicts. Maybe two people change the same line of code in a file. And the administrator would say, okay, I've seen that these two people are changing it the same way, and they have to choose which one they want to accept. What I'm going to do now is go through an example, sort of imagining that there's two people working on a repository, and you'll see what that means. So here's my GitHub here. GitHub, like I said, separate from Git. This is where you store code. GitHub is like a hub for, you have your repository, you upload them, and then this is where groups of people can work on repositories together. So what I'm going to do is I'm going to create a new repository and we're going to download it to our computer. So here I have new repository, and I'm going to call this Git tutorial group. So this is our group exercise for our tutorial. I'm going to make it a private repository, meaning that only the people that I choose have access to it. But in this case, it's only going to be me again. I'm going to add a README file. This is like something that is just a file that's put in the repository, and I'll go create repository. So now I have this empty repository. So what's going to happen is there's this repository, and there's going to be different people working on code in different parts of the repository. So what you need to do is take this repository from online and put it on your computer, and different people are going to be putting it on their own different computers. And the way you do that is if you want to clone it, that's what it's called, cloning repository. You clone it from this link here. So I copy this. And what I'm going to do on my own computer is I'm going to have two separate files corresponding to the same repository, but it's like as if two people were working on it separately. You'll see what I mean. So here's the link that I clone the repository from, and I just use the command git clone. I copy and paste this link, and I'm going to call it person1. So that's the name of the folder. So here I go like this, clones into a folder known as person1, takes all the code. I look at my directory and I have person1. This is like its own Git repository. So one person has cloned the repository, put it into their own folder. I'm going to do it again. So this is like if I'm simulating two people are working on the code. I'm going to clone the same repository, but put it in a different folder. So they're in different folders on my computer, so they're separate. And it's the same thing as if those folders were on two completely different computers. So I have person1 and person2. I'm going to make changes in each one of those folders, right? So it's like two people are working on the code, and we'll play around with a few examples. So for example, suppose person1 is in charge of developing Python code. So I'm going to cd to person1. And again, I can go git status. And it shows that it is indeed a Git repository, and we can start working on things. So suppose person1, right? I'm person1 here. I have the Git repository. I create some new code. I'm going to call it Python code.py. So they're working on all their stuff. They've edited the repository, and maybe person2 here, they're working on C code. So I create a new file. I'm going to call this ccode.c. So each separately, they're both working on their own different parts of the project. So now here I am person1. I've just made my python code.py file. I'm in my person1 directory. I go git status, and the python code.py is there. And for person2, again, suppose I'm on another computer here. So here I am, cd git tutorial, cd person2. So here's person2. So this is like terminal here is person2. This terminal here is person1. So if I go git status here, this is person2. They say, okay, well, I've added my C code file. Person1, well, they've added their Python code file. These are separate folders. It's like if they were on different computers, each person working on the code. They don't talk to each other. Each folder is the Git repository structure. So I make sure to add it. I go git add star.py, and I go git commit, add a message, and I'm going to say add Python code. So this is person1. They've added it. And now they're going to make their own development branch. So I'm going to go git checkout b Python, or I'm just going to call it person1. It's typically a good idea if like it's a small group and they're separate people, just name the branch after yourself. So I'm going to call this git checkout b person1. So now it's got all that Python code. Same thing with person2. I go git commit dash, or git add initial, git add star.c. We'll add the C code. It gets it ready to be snapshotted. Git commit dash m added initial C code. And then I'm going to go git checkout. It's going to be a new branch for the C development. I'm going to call it person2, because this is the stuff that person's2 doing. I need to make sure, because it's a new branch, I add dash b. So now I have the person2 branch. So person1's added their code, and now they want to publish it to the main repository, right? In their own development branch. So I go git branch. I'm in the person1 branch. I want to push this to GitHub here. And there's separate branches on GitHub. Right now there's only main because it hasn't found any changes. If I go git push, it will tell me there is no person1 branch on GitHub here. But if I want to add it, I can type in this command. So now it's going to make a new branch on the sort of online hub of where the code is taken. So I go git push like this. And now there's a person1 branch up here. So if I reload this, now there's a couple branches. I can go main to person1. And now I have python code.py here. So this is the person1 branch. Again, there's nothing new on the main branch. And the same thing for person2. Maybe they do that as well. So I go git push. Again, it will tell me that there is no person2 branch on GitHub. But if I type in this command, it will give me that. It will set that new branch on GitHub. So now there's person2 on GitHub like this. And so if I reload this page, you'll see that there's now a person1 branch and a person2 branch. The person2 branch contains the C code, and the person1 branch contains the Python code, because they're each working on it separately in their own development branches, which essentially is what's been done here. Now, if I go to the main branch, you'll see that there's none of that code there. And in order to add that code to the main branch, the best practice is to create what's known as a pull request on GitHub. So I'm going to go to pull requests, and suppose I'm person 1, and I say, all right, I want a new pull request. I want to merge person 1 to main. I want all the code that I've developed on my branch to be put on the main branch. So I go create pull request. And I'm going to say, I'm just adding my Python code. So I create the pull request. It's all good. There's a pull request that's been generated by person 1. And now the leader, which is also me in this case, I'm only a single person. I'm just simulating multiple people. They'll say, okay, well, person 1 wants to merge his Python code. There's no conflicts. There's nothing. That's fine. I'll just merge this pull request and I'll confirm the merge. So that's good. Now all that Python code has been merged to the main. So I can go to my code here, and now the Python code is there. So I go back to pull request. I'm person 2. I want to merge my stuff as well. New pull request. I want to merge person 2 to main like this. I create a pull request. It's able to merge. There's no conflicts of any code. I create the pull request. It's been created. Checks for stuff. Okay, it's all good. You can merge the code. You both haven't edited the same file in the same way, and I can merge the pull request. This is the leader of the group that will do this. You'll have usually one person in charge for doing this. So, okay, it's been merged, and I go to code, and you can see that my main branch here now has both my C code and my Python code. By the way, it's called main here. It's called master on my computer. They recently changed the naming of this. So I have an older version of Git on my computer, but this is what's known as the main branch on GitHub. So the next thing is, suppose I'm person 1 and I'm developing all my Python code, but for some reason I need access to the C code. And if I go git branch, see I'm on the person 1 branch, and if I go, there's the main branch there, I can go git checkout main. I'm on the main branch, and I can go git status. It's all like this, and I go git, I can just look at what's in my directory, and I don't have the C code. I only have the Python code. And if I want to take that C code, right, it's the person 2's uploaded it online here, so it's here. If I want that to be pulled to my repository, I need to go git pull. So I'm in my main directory here. I've switched to main, and now I go git pull. And now it will take all that code online and it'll push it here. And now if I look at my directory, I have my C code and my Python code. So if I go to my folder structure here, remember I'm person 1, I now have my C code, my Python code, and everything. So person 2's put it online and I've taken it to my computer. So I have access to both things. So if I look at my sort of whole process of what's going on here, I started here, this is the bottom, and I initially created the repository. And then there were 2 people that were working on it, person 1 and person 2, and they took from that and they each had their own development branches. So person 1 comes up here and they took a snapshot. Remember, the star is a snapshot in time of the folder structure. And here they added the Python code, right? And then it went here like this along this blue path, and then it got merged back to main online, right? I created a pull request online and I merged the 2 branches back together here. The same thing happened with person 2. I went from the main branch here, then there's a commit here. Remember, this branch is separate. I added my C code. And then after the Python code was added, you'll remember the order of this video, I added the Python code first online. Then I created the person 2 pull request online. And then I merged that to master. And so at the end, it has both the code from this green branch, the added C code, and the added Python code. It's all now on the main branch. So now we start getting into a little bit of fuzzy area here, and this can get really complicated, and this is mostly just an introduction video. But suppose I'm person 1, right? And I'm happy in my directory, I'm working on my Python code, and maybe I'm using a little bit of the C code that someone else has written. But I notice there's a bug in the C code, and it's not my job to work on the C code, but I want to fix this bug so that it works with my code. So I'm person 1 here. And I open my C code here, and maybe there's a bug, and there's a line here, and I just fix the bug. Again, this is just notational, so I've changed this file by fixing the bug. And now I've changed the C code, so now it's different from person 2 who's working on the C code. So then I add this to my new snapshots. I go git add star.c, since that needs to be added again, and then I go git commit -m, a fixed bug in C code. Right? So that fixed a little bug. And now I'm going to push it to GitHub. I'm on my Git branch. And I've done this in main. You'll see I'm in the main branch, but you never want to push directly to main on GitHub. It's very bad practice. You want to work in your own branch. So I'm going to check out person1. Now I'm in person1 branch. I'm going to merge this with master. So all the code from master gets copied back into person1 branch. So not master, git merge main. So I'm merged with the main branch. I go git status. Everything's good. And I git push. And now this branch will be updated on GitHub, the place where all the code is stored. So if I go over to GitHub and I reload here, okay, you can see this is the main branch. There shouldn't be any changes here. So it's not showing the fix bug thing that I changed because I only edited my branch, the person1 branch. So I go to person1 and now I have ccode.c and you can see the commit where I fixed the code in the C. So there's a line here, fix bug. So something was changed in that file. And now I put a pull request. I say, hey, guy working on the C code, there was a bug in your code and I fixed it. So I go new pull request. I want to merge person1 to main. I'm fixing the code of your C code that there was a bug, and I want this to go back into main so that people who have access to the main branch of the code, which is where people download it from, they're not running into this bug. And I found it. Even though I'm working on the Python code, I found your C bug and I fixed it. So I create a pull request. And I'm going to say, yeah, fixed bug in the C code. I create the pull request. So I'm working on the Python code, but I fixed the bug in the C code, right? And so now the leader of the group comes along. They say, hey, person1 is, they want to merge a bug in the C code. So I would look over and see what they did. And I would merge the pull request. And I confirm it. So now it's been merged. And so now I'm back in... If I go back to just the main repository here, I go to C code, and it has indeed been put into the main branch here. So now I'm back to being person2. So maybe I haven't done anything to my code, but I know that there was a thing that was changed on GitHub. So I want to take my new C code. I can go git checkout main. I want to, go back. So git branch. I'm now on the main branch, and I can pull the new code from GitHub. I go git pull. So I'm pulling the new main branch, right? So now I have all my new code. And again, if I look at my file here, and I'm git repo person2, and I'm in my main branch, and I open ccode.c, the fix bug has been put in there. So then I say, okay, now I check out my development branch. I'm going to my person2 branch, and I go git branch, and I'm in person2, and I merge with main. So now my branch has that update that person1 did to my C code. Now I'm going to go through another example here that has to do with editing a big file. So suppose people are working in the group and they find that they need this big Python file that everyone's going to use. It's person1's job to create this file. So I'm going to go to, on person1 here. I'm going to make sure git branch. I'm in the person1 branch. So I'm person1, I'm on my computer, I'm in git repo 1, and I make this new file. And I'm going to call it big Python file. And everyone needs this file. It's very important, .py. I'm going to even add some lines to it. I'm going to go open. I'm going to go, this is line 1. And they're writing their code. And they have a bunch of code they wrote here. 1, 2, 3, 4, 5, 6, 7. So there's 7 lines of code in this big Python file. Again, this is all just for, this is all just a dummy example. This isn't actually any code. And so I save this file, and I want to put this on the main repository so that people can find it. I just realized I added that to the wrong directory. I'm in person1 directory of git tutorial, my big Python file.py. I've just added it. And I go git status. And there's an untracked file, so I go git add star.py. I'm going to add that to the newest the newest snapshot I take of my folder. Git commit -m add big Python file, like that. And then I go, so it's there, it's on my branch, and I can git push that to GitHub. So it's on git push. Now in my person1 development branch, if I go to GitHub, you'll see here that I have my big Python file.py. And now I want to create a pull request so that everyone in the group can see it. I want to merge this big Python file here to main, which currently it is not in main. It's only in person 1. So I go pull requests, create a new pull request, and I'm going to say, I want you to put the code in person 1. This includes my big Python file I just made. I want you to merge this to main. I'm going to create a pull request. So here I create pull request. I'm person 1. The leader of the group says, all right, there's a pull request that's been done. I want to merge this pull request. Everything looks good to me. And so they add this code to main. And now if I go back to the code here, on the main branch, I have my big Python file. So person 2 might see this, and person 2 says, hey, there's the big Python file I've been looking for. They go back to their terminal, which is here. I'm person 2, and I git, what branch am I on? Git branch, and I go git checkout main branch. So now I'm on the main, and I go git pull, and this will pull the branch. Now I have my big Python file, .py branch. So now I have big Python file here, and I go git, again, I can look at my folder here for, well, git branch. I'm in the master branch. I have, in the master branch currently, I'm person 2, I have big Python file.py. If I switch branches, git checkout person 2, I'm in my development branch, but you can see that in my development branch, I don't have big Python file.py, so I have to merge the new code in main to my development branch. Since person 1 put it up there, it was merged to the main branch online, but person 2 didn't know about that, and so they have to get that new code by pulling to their main on their computer and merging to their development branch. So I git merge with main. So now I have my big Python file here, and I go, and I look in my folder, and sure enough, here it is. So I'm person 2, and maybe I edit it. So this is where things get tricky. Suppose I'm person 1, and I add, or person 2, and I go person 2 contribution. So I edit this file in this way, right? And maybe I'm person 1, and I do something different. I'm also editing this big Python file. And I say, well, I'm going to add something here, person 1. So they've each edited the file in their own different ways. The question is, will there be a merge conflict on GitHub? Right? So we've each edited the file, we've done separate things, and now we want to push it. And will the combination of those changes be done? The answer is yes. So I'm person 1, I made those changes. I go git, first of all, git status to see what's going on. That's been modified. Git add star.py, it's going to be included in our next screenshot. Git commit -m, edited line 7 of big Python file. So I edited that line, and then the same thing, and I pushed that. Git, and again, if I look at my branch, I'm on person 1, and I go git push. And it pushes to the person 1 branch on GitHub. Person 2 does the same thing. I go git status. Okay, this file has been modified. Git add the Python file. Now I'm going to take a snapshot in time of my file structure. Git commit.m. edited line 1 of big Python file. And I push that to GitHub. Git push. So both have been added to GitHub. And so let's take a look at what actually happened here. Remember, each person did their own changes to the same file. So if I look at my person 1 branch and I look at my big Python file, they added something to line 7. And person 2, well, person 2, they added something to, oh, this is the wrong file. Person 2, they added something to line 1, right? So they each made their own contribution to the file. And we want those, changes to be both made together. So, okay, suppose I'm person 1, and I say, all right, I'm creating a pull request. I'm person 1. I want my change in that big Python file to be made. So I create a new pull request. I say, all right, I want person 1 to be merged to main, and the changes that are occurring are in that big Python file. I create a pull request, all right, create the pull request, and the leader of the group says, all right, I see you've changed big Python file. I'm going to merge it. So now it's been merged to main. But then person 2 comes along and says, well, I've also changed that file. So I'm going to create a new pull request. And I want you to merge person 2 to main. And you'll see that there are actually no conflicts, even though we've changed the same file. All right, checking for conflicts, and there are no conflicts. And I'll show you what the end result is. So I merge the pull request, confirm the merge. And let's go back. Let's see what the main branch actually looks like, because we've each made changes to this big Python file. And you can see that both contributions to the file have both been made. Now, it turns out that those sort of things work. If you delete lines, Git knows if you delete lines, it knows to shift everything up. It knows how to sort of take into account a lot of changes. The only thing it can't do is if you both edit the same line. So I can switch to my master branch, git checkout, or main branch, and then I go git pull, and I'm going to get all that new code, right? So if I look at my file here, and I'm person1, and I look at big python file.py, it's been updated for both persons' contributions, right? And suppose I make a change. I'm going to go, I want person1 stuff here, right? And I save it. Well, actually, I make sure to only do this in my development branch. So I go git checkout person1. So now I'm in my branch. And once I'm in person1, you can see that, okay, the change is no longer there. And it's because I need to merge my branch, which is older, with the new main branch. So I go git merge main. All right. And now I look at big Python file again, and you can see that it's been done. So you see the sort of structure of what's going on here. I pull from main. I put this into my branch, right? That's what's being done. I never pull branch to branch. Everything's done in main. I pull to main, and then I put all those changes into my own branch. And that's what's been done here. And now I have the contribution from person 2 as well in my own development branch. And so maybe now I want to make a change. I go, I want person 1 stuff here. I save it. So I made a change to line 4. Person 2, they do the same thing. They go git checkout. They're on the main branch. Git pull. So they're pulling stuff from GitHub to that branch. Git checkout person 2. So now they're on their own development branch, and they go git merge main. So now person 2 also has all those new changes from both person 1 and person 2 on their own development branch. So I'm person 2 here. I look at big Python file. Okay, we have contributions from both people, and we're not on the main branch. We're in the development branch. So then they say, I want person, or slightly different. No, I want person 2 stuff here. So these two files are different, right? This one says, no, I want person 2 stuff here. And this person 1, it says, I want person 1 stuff here. So what happens if they both publish to GitHub? Well, let's see what happens. So remember, they're each on their own development branch. So it will be person 1 branch on GitHub and person 2 branch on GitHub, right? That'll go to each one of these branches, and I'll create those pull requests, and there'll be a sort of, issue where they're, contradicting each other. So here I go, git status. I need to add it. So git add star.py, git commit edit line 4 of big Python file. And then I go git push. So it'll push that up to GitHub. Same thing with person 2. I'm on my person 2 branch. I go git add star.py, git commit message edited line 4 of big Python file. Right? So I've edited it. Now I go git push. So now it's pushed to person 2's development branch on GitHub. So if I look here, I'm on person 1 branch on GitHub. I want person 1 stuff here. Person 2 branch, no, I want person 2 stuff here. And back on the main branch, right, there's nothing that's been done yet. It's still the same as it was before, right? And now I want to merge each one of those things to main. Person 1 and person 2 have done their own things. They each want to merge to main. So I'm person 1. I create a new pull request. I say, I want you to merge person 1 to main. They've won. They're ahead of person 2, so they get their changes first. And because, they're doing their own stuff, there's no conflicts or anything. They've just changed a line. That's fine. Checking for compatibilities, and I merge the pull request. I confirm the merge. So now if I go back to main here, and I go big Python file, person 1 got their stuff there. But now suppose I'm person 2. I've also worked on that file, and I create a new pull request. And I'm person 2, and I say, I want you to merge person 2 to main. I create this pull request, can't automatically merge. There's an issue, but you can still create a request. So I create the pull request. And now I'm the person who's in charge of accepting this merge, and there's a conflict. It says conflicting files, big Python file.py, and I have to go to resolve conflicts. And you see where the conflict is, and this is where Git is really genius. It knows exactly where that conflicting issue is. Well, person2 branch has this stuff here, but the main branch has this here, right? So this is the main branch, what's currently on the main branch. This is what person2 wants. So I can make the change as the head developer, the lead developer of this code. I can look at these conflicting things and say, well, actually, you know what? I don't like so much what person1 did, so I'm going to delete this, get rid of this, and I'm going to take what person2 did. And so this is the new file, and I'm going to mark this as resolved, right? There was a confliction, and now I've resolved it. I'm not taking person1 stuff, I'm taking person2 stuff. And I commit the merge. And now I have to merge the pull request, and I confirm merge. So now that I've confirmed the merge, I go back here, I go to big Python file, and you can see that I've accepted person2's change and not person1's change. So anyways, this is rarely an issue, right? Usually people are working on their own files, but it occasionally happens in sort of more complicated projects that people are working on the same file. And it's the role of the person who's in charge of the code to go to the pull requests and say, well, two people have done, separate things to the same part of the code. I have to decide which one is accepted. Anyways, I hope this was a straightforward tutorial to Git. If you want to see more of this stuff in the future, please let me know, and I'll see you next time.